Hello, my name is Ben Branco. I teach freshman level Algebra 1 to 6th, 7th, and 8th grade advanced students outside of Cleveland, Ohio. I've created this blended learning course on parabolas and quadratic models for my students. Additionally, I've kept their parents, my administrators, and some colleagues that want to join me on this blended learning journey in mind so they may follow along with this course or use some or all of it for their own consumption in teaching. This unit is based on the Ohio State standards. From these standards, I've created a 3-column table using Fink's layout. It identifies and aligns the learning goals, activities, and assessments. From the 3-column table, I created a course outline that breaks down the learning objectives and assessments on a weekly basis. I used Fink's 3-column table to create this unit because I think this design basis for the course is a great way to make a big picture roadmap of the unit. As teachers, we sometimes get lost in the activities and forget how these activities relate the learning to the assessment. However, with Fink's layout, you set the learning goals first, then the assessments for learning, and finally the activities that will actually construct the knowledge and understanding for the student. I enjoy that with Fink's table, you are forced to set goals that aren't simply at a foundational level. In mathematics, we often get blinded by the numbers. So being forced to step back and take a broader look at the goals for the course and incorporating goals like integration and human dimension can truly amplify the learning for my students. I created this unit using both competency-based education and outcome-based education. I am a state-tested subject, and even more so, I am a required class for graduation, meaning students must pass Algebra 1 before they can earn a high school diploma in the state of Ohio. Because of this reason, I must address the state standards in a concrete, competency-based way that promotes the student to be successful in passing the graduation exam for the course. I address these standards in the foundational and application levels of the 3-column table and assess these categories using formative and summative assessments. The outcome-based education of this unit focuses on students applying this knowledge of the standards to real-life application. Students will have a few different avenues to display their understanding and application of a quadratic model, allowing students some choice over their learning. Students will be able to hear from local professionals who use quadratic functions to maximize profits and space before creating a product or laying out a space that is optimized given a situation with parameters. Finally, we will circle back to this unit at the end of the school year and allow students to model the parabolas that quadratic functions make using the digital tool Desmos. Students will choose one of 2 field trips where they will take precise measurements of roller coasters or bridges, create an equation that mimics the parabola of the coaster or bridge, and finally design a model of a coaster or bridge using a digital tool. Along with the digital creation of their model, students will summarize their learning, understanding, and application of polynomials and quadratic functions on their e-portfolio and share it with the community. I will balance the assessment of, for, and as learning in this unit in the following ways. Assessment of learning will be done at the foundational and applicational levels via the formative and summative assessments. Students will also be assessed for learning by creating graphic organizers that help them factor polynomials. Assessment for learning will be done as students have in-class and online discussions with their teammates and the whole class, pertaining polynomials and quadratic models. This will allow them to ask each other and myself questions. From the questions and the discussions that I overhear, I can alter the lessons and create small intervention groups to address the gaps and misunderstandings that students may have. As far as the assessment as learning, this will be completed when students have to take precise measurements of the coasters and bridges using mathematical instruments and then use those measurements to create a quadratic equation to model their object and finally create a digital model and written reflection about their learning and understanding. Ultimately, the students will be assessing themselves on the modeling activity. What did they learn? What could they have done better? What would they change? Was the plan that they created ultimately effective? And finally, they'll present this model and reflection of their e-portfolio to the community on graduation night. Now we have switched over to my website. Pi is greater than pi, particularly the portion that is on course design. On the website here, I have my 3-column table, and I've also embedded the outline of the program. I'm going to access these through a Google Doc because it's a little bit clearer to understand. Using Fink's 3-column table, we have our learning goals, our assessment activities, and our learning activities. The learning goals are broken down into foundational knowledge, application, integration, human dimension caring, and how to keep learning. Since this unit covers polynomials and quadratic models, we begin with foundational and application knowledge of what polynomials are, how to work with them correctly, as well as to what is a quadratic equation and the important aspects. In these two levels of the learning activities are pretty standard sit and get, but the assessment activities allow the students to use more digital sources to create graphic organizers and to manipulate quadratics on websites. We then move into the integration, the deeper level thinking aspect. Here, students will be able to use their foundational and application knowledge and apply it to real life scenarios that sales experts, architects, and roller coaster designers use to optimize their business or space. Next, we're going to look at my outline. In this outline, we start in week 1 on the basics of polynomials, such as adding, subtracting, multiplying, and those minor basic principles. The assessments here are formative to ensure that students are getting the correct vernacular and accurately making mathematical processes. The second week of the unit is spent factoring polynomials where there is a greatest common factor or the leading coefficient is 1, as well as applying the basics of multiplying, adding, and subtracting polynomials to do two-dimensional shapes such as picture frames and a bird's eye view of a swimming pool. Assessments during work 2 will be more standard pen and paper mathematical problems. In the third week, we complete the hardest material of factoring special case polynomials, and we finish out this week by creating a graphic organizer, a flowchart for how to factor polynomials. Students will then use this digital flowchart for the remainder of the unit, tinkering with it as necessary to better suit their needs. Week 4 is the conclusion of the main unit, where we have presentations by local sales experts and architects about how they optimize sales and space using quadratic models. Students will apply their understanding of parabolas by creating marble slides on Desmos and working out scenarios that the architects and sales experts have experienced in their field. Finally, we circle back for a mini 1-week unit where the students really interact with and see quadratic models with their own eyes. We take a field trip to explore roller coasters at Cedar Point or bridges in our hometown of Lakewood. While observing these real-life quadratic equations, students take precise measurements of them and recreate the coaster or bridge as a quadratic equation. They then model this equation using digital tools. Finally, after they've created the model, they will write a reflection about their learning and why quadratic models are beautiful observations in everyday life.